In this video, I'm going to share with you my exploration of creating VCarve inlays. Now, I've never created a VCarve inlay before, so I'm doing this from a complete beginner's point of view and sharing this with you in this video. So what is a VCarve inlay? So an inlay is basically where you cut artwork into two different materials, a male and a female part that you bring together to create a flush, contrasting design, just like the examples that you can see here. And a VCarve inlay uses a VCarve toolpath to create the inlay, whereby we're creating a beveled inlay. So do not get this confused with the auto inlay feature that we have in the software. We're doing this as a technique that's using the VCarve toolpath. Now, inlays rest in their respective pockets by contact along the sides of the inlay and the pocket. Okay, so this would be the male part that slots into the female inlay where they make contact, and that's how the two join together. And using a V-bit tool rather than a flat tool just ensures that we are not limited to the radius of the tool. So that way we create the beveled edges, and also we are able to create inlays with very sharp points and corners, just like some of the examples that you can see here. Now, this technique was created by customers Paul Zank and Damien Durant way back in 2006. And they shared this technique on the Vectric forum. So if you go to your internet browser, go to the Vectric forum, and in the search bar here, type in a simple way to make inlays, and you will find the original thread created by Paul Zank, all about how to create the V-carved inlays using the VCarve toolpath. Okay, so the thread explains everything, how to create inlays, the concepts, what's actually going on when we're creating inlays, and here many other users have shared their examples of their inlays, and you can see it's 24 pages strong right up until very recently. You can see that the thread is still current and people are still referring to this for their own knowledge of creating V-carved inlays, and this is pretty much what I went by. Now, if you go to page 1, what they did do was Paul actually created a document, okay, the VCarve Inlay description and procedure.pdf, which I think has been updated further on in the threads, but it basically gives you a walkthrough of how to create them. And this is what I use as my start point to create my inlays. So how do we create an inlay? So first off, you're going to need artwork or vectors, or you're going to create your vectors from the artwork that you import into the software. Now, your first set of vectors, so here I've simply traced around the compass rose, and this is going to act as my female part. So this represents the female pocket that I'm going to carve into inside of these vectors. Now, you need to create a male counterpart, and so the idea here is you take the female vectors and you basically mirror them to create the male part, and then there you have a male set of vectors. And the idea is you cut the female and the male parts with a VCarve toolpath using the exact same tools. So here is the female part, here is our male counterpart. The idea is you glue the two parts together, and then you basically skim the material flush to reveal the inlay. And it really is that easy. So let's take a closer look at the female inlay. So you're going to start with vectors for the female, and you're going to machine everything inside of those vectors using the VCarve toolpath, where we specify a flat depth of whatever it is you want to enter in here. And so the idea is we're basically cutting into the vectors whereby we're creating a beveled pocket. Okay, right then, easy. So now we go on to the male inlay. So for the male part, we need vectors for the male. So those vectors are the same as the female, except they've been mirrored over. You need to create another vector, say a square that goes around the outside of the part, to specify your boundary that you want to cut away. Because for the male, we're machining everything outside of the vectors this time to create a raised plug part. So everything that is purple here is what will be machined away using the VCarve toolpath. Now it's important that you use the exact same tools that you use to cut the female inlay for the male inlay, otherwise this is not going to work. Now, in terms of our cut depths, the difference with the male here is that we also apply a start depth and a flat depth, and the total combined value here must be equal to the flat depth that we specified for the female part. And so, why are we creating a start depth and a flat depth here? Well, the reason why we include a start depth is that allows us to drop the tool down to cut more of a bevel so that it can fit snug within the female. And so this start depth basically represents our male insertion, how much of the male part is going to go in to our female pocket, where the two are glued together and basically mate at the pinch points or the areas of contact as that goes into the female part. And so to summarise, the inlay pocket, our female part, is going to be cut inside of the vectors like you can see here, where we specify a flat depth and we specify our tools that we're going to use to cut the female part, and that will create this beveled inlay pocket. And that's what it would look like if we was to cut that out. The male side, the cutting depths, a combined total of the cut depths must be equal to that of the flat depth of the female part. We must use the exact same tools that we use for the female part in order for this to work. And so dropping the start depth down just means that we basically cut more of the bevel in order for it to fit inside of the female pocket. Now you must be mindful of your start depths, ensuring that they're safe and appropriate for the tools that you are using, because the tool will plunge in at the start depth and continue to cut into the flat depth according to your pass depth. Okay, so the first pass will be at the start depth plus the tool's pass depth or the flat depth if that is less. And if this doesn't make sense, you don't need to worry about that. This process works, so just follow the steps in this video. Now, in terms of your V-bit tool, one important thing to think of is that you want to make sure that the length of the V-bit tool is longer than the depth that you intend to cut down to. And you also want to make sure you measure the angle of the V-bit tool. Sometimes the tools can tell you it's a specific angle when in fact it actually isn't. So try and be very accurate in terms of your measurements and then what you input into your tool selection. So in terms of machining, first off we're going to cut the female and the male parts with a VCarve toolpath using the exact same tools, but we're cutting into different materials per male per female. Once you've machined those, you're then going to glue the two parts together, clamp them shut, leave overnight to dry, and then tomorrow you can go ahead and skim your material flush, and that's pretty much it. And this is the satisfying moment that you will reveal the inlay that you've been working on. And it really is pretty easy. So now that I had an idea of how inlays work with that successful compass rose, I decided how I could take this a stage further, and I thought about creating inlays within inlays. And so what I did was I scoured the internet for something that I think would be quite nice to create an inlay from, and I thought about doing the Tudor rose. So here we have green leaves in the background, we have a red rose, a white rose and a yellow centre part of our rose. So this image I managed to get an SVG file, and this is basically a vector image, and these are the vectors that I used, and I trimmed some of them up, and you can access all of the files from your project folder. So all the files that you get access to are all here. Okay, so you've got all of the different inlays ordered by 1 to 6, and we'll talk more about these as we progress through this presentation. Okay, so how are we going to create the inlay? So the first inlay we'll create is the leaves. Okay, so we're going to cut the leaves like so. Once we've done that, we're then going to cut into our first inlay where we have the mated female and male of the leaves, and we'll cut into that to create our second inlay, which is the red rose. Now for the white rose, I'm going to leave that as our initial first inlay material. So we're just going to leave that there, and that will be enough to create the contrast between the two different inlays we have so far. And then the third inlay will be the centre part of our rose. Right then, so let's have a look at how the build went. So first off, I gathered contrasting material to use for the 4 different elements of our design, and with that I began to create the first inlay. So first off, we're looking at the leaves here. Okay, so this is the female part, and that's what we're cutting. Now, from the research that I've done, I've read that it's more appropriate to glue the male and the female part together and clamp them together. That way you have even pressure underneath and on top. And so that would require me to take the female part of the inlay off of my machine in order to do that. So what I had to think about right from the get-go was, how am I going to basically re-register my part when I cut further inlays into my initial first female part. So what I did was I drew up some dowel circles in the software and basically applied a profile toolpath cutting inside, where I went all the way through the material and a little bit into my spoil board. Kind of marked on the spoil board where those dowel holes were, and also made a note of my X0, Y0 positions from my CNC machine's home start position. And so these values became important to me throughout the process of creating these inlays, as I was always able to refer back to this point where I could locate my material, and everything will be aligned correctly in terms of the X and the Y values. And so, using the same toolpath setup that I used for the compass rose, I was able to machine the female part like so, along with the male inlay, which is this part here. Now, I read on the forum and experienced it myself, and that was fuzzies on both of the male and the female cuts. So you really want to clean up those before you glue the two parts together. So here I just used a wire brush to clean it up until I had quite a clean project to work with, where I was ready to glue the two parts together. Okay, so I glued both the female and the male. You also see that I actually made a note of my X0, Y0, so I know that it was this bottom lower left hand corner, so when I come to align everything back, it was from this point here. Okay, so glue both the female and the male. Okay, put the male into the female. Try and really make the pressure even around the entire part, because otherwise you could look at applying more pressure one side and you're going to have a funny looking inlay because it wasn't pushed in at the kind of even pressures that you need it to. Okay, so you can see that part there. And then you'll leave that to dry overnight, and then you simply cut away or skim away the excess material. Now, from my findings, reading all sorts of comments on that thread on the forum, quite a lot of people actually put this through a bandsaw, and so that's how you'd take the male part away from the female. Now, I don't have access to a bandsaw in our workshop. I only have access to a CNC. So I'm basically skimming my material off using a pocket toolpath on top of our original female inlay. So you do what's best for you. If you've got access to machines that make this process easier, then do that. I'm just showing you what I've done in my own experience. And so with that skimmed away, created the first successful inlay as part of this Tudor rose. Okay, so you can see how that looks there. Okay, so with that, we lined up the original female inlay with the registration pins, and then it was time to cut the second female inlay. Okay, so this is the red rose, and it's also the center part of the rose itself. Okay, so this is what the first toolpath looked like, using the end mill to create the pocket part of the inlay. And this was really scary stuff watching this, because you're watching the machine cut away at something that looked so beautiful earlier, and something that in terms of the glue time that you have to wait, the 24 hours, just be cut away like this. And this is actually where my troubles began. And so when I introduced the VCarve toolpath to cut the rest of that inlay, this is what happened. And so you can see that one of those leaves broke free. So let's take a closer look at what is actually happening with the inlay now that we can actually see into it. So, having a look here, so the start depth for our first male inlay is actually too small for this design and for multiple inlays. So we had a start depth of 0.1, so that means 0.1 of our male part is coming into our female counterpart of the design. And then we have a flat depth of 0.2, so there's a 0.2 space underneath, which we would leave for glue, but we can clearly see here we have a void there. And so there's two things here. One is that we have quite a large flat depth here, which is empty space, and two, the design is actually quite fragile without the material underneath, and so we have to kind of be conscious of what's going on underneath as to where there's going to be contact for the male part when we're recutting into it to create the next inlay. And so really, I guess in this circumstance, we needn't have such a big glue gap. So then I decided to change the start depth and the flat depth. Okay, now I made some drastic changes here. So I went to the start depth of 0.28 and a flat depth of a very small 0.02. The idea of this is that it will give me more male insertion with a much smaller glue gap, and hopefully this would provide more stability cutting into delicate areas of my design. And so I must be mindful of my start depth and flat depth in terms of how much of my tool is going to plunge straight down into the material. And I feel that with the tool that I'm using, I'm confident that this is going to be okay. But you must ensure that you are using settings that are safe and appropriate for your examples. And so I've drew up a diagram in the software that you can access called Inlay Vector. And so the idea here is I just want to show you a comparison of what I did previously to what I'm about to do. Okay, so when we're creating the male part, our tool is coming down at a start depth of 0.1 here. And so where the tool drops down to, it's going to create a bevel that would look like this. Now, increasing that start depth and then decreasing the flat depth to accommodate for the total flat depth here, our VBit tool comes much closer in, and therefore we're going to cut more of it away. So if we take a look at how that would look, so again in comparison, start depth of 0.1, flat depth of 0.2, but with a start depth of 0.28 and a flat depth of 0.02, we're cutting much more of it away, so much more of this will ultimately fit in to our female counterpart, like you can see here. Okay, so this is the contact point at the start depth of 0.1, and then this is the contact point at the start depth of 0.28. So starting again. Okay, so I've got my female part, made a note of my x0, y0 in the lower left hand corner over here. And again, I made sure that I wrote down the positions of my machine for my x0, y0, so I could use that to constantly align my female part when I come to create the further female cuts. Okay, so the first cut for the female looked like this, and then here is the male part. Glued the two together, clamped them up, and that's what it looked like on top. So let's do a comparison. Okay, so my first example, you see I have a much higher gap, only 0.1 of that male is going into our material, whereas this time we have 0.28 of our male going into the female, and you can see it's much tighter here. So leaving that to dry overnight, the next day I come to skim the material. I'm left with something like this. You can see I have actually gone into it a little bit too deep, but that's not too much to worry about just yet. Okay, so successful inlay there, and now we're ready to cut the second female part. So again, we're looking at the red rose, and then we have a successful V-carve of the female inlay for the red rose that you can see here. And so just to compare what we had before, so this is with the start depth of 0.1. You can see we can actually see through that there, and here we have much more of an insertion, so this is making this much more structurally sound for this particular design that I'm cutting into. And so with that as success, I go on to create the male part for the red rose, the male part for the center part of our rose, and then we're ready to glue up the male red rose into the female pocket, like so, clamp it up, leave it to dry overnight, and then skim back the next day. Okay, so there is the rose, and you can see that I was a little bit too excited about the glue up here, and quite a lot of it has seeped out, so I've just sanded that back, and this is what we are left with. Okay, so now all we need to do is input the plug for the center part, so that's that in there, and I've skimmed it away, and I just need to skim it a little bit more to get rid of that glue seepage, and there I am left with my final inlay. And then I basically ran a profile pass around the outside of a circle to cut the part out. And that is my experience of creating inlays. And these are really effective looking pieces of art that can be done ever so quickly in the software and can be cut very quickly on your machine. The only time consuming part is the 24-hour wait for the glue to dry, but they make some really effective looking pieces of art. So what have I learned? So everything that I have learnt has all been down to my own research from other user accounts and their experiences of creating their own inlays. So if you want to create an inlay, just simply follow the steps that I've walked you through in this video and you are sure to have success with creating your first inlay. Now, the things to be mindful of is that you'll need to modify your start depth for the male inlay, all dependent on your design. You saw in my example that for the compass rose, the values that I used here worked perfectly, but then they appeared to be a problem for me when cutting into the Tudor rose, and that could be also to do with the actual design itself. But the idea was that I wanted to create more male insertion just to give that more of a structurally sound environment for me to recut into. And there is a wealth of information over on the forum for you to read other users' experiences and to ask questions.